Okay, so it's not the most elegant way to use Excel, but certainly it does have the capability to do this. One of the things that spreadsheets are designed to do is a level of statistical analysis. So it does have a lot of statistics built into it. Now you don't need to have any data entered here at all, none at all. All you need to do is go to an empty cell in any worksheet anywhere, and we need to input the command, and it's a little similar to the calculator if you watch that video. The parameters are in a little bit different order, and the command is a little bit different. But so anyway, you go to an empty cell, and then what I did up here is I went to the Formulas tab in the ribbon. And there's a lot of formulas up here. There's a whole big bunch of them here. There's one for a whole lot of mathematical formulas. Oddly enough, what we want is actually under More Functions. That's where we find the statistics. Here's an odd thing for you. Statistics is not math per se. It's an application of mathematics. So it doesn't fall under the math category there. It falls under kind of its own category, much the same as engineering would. We're looking at an application that uses mathematics very heavily, but isn't entirely all mathematics itself. All right, so in the statistics menu, as you might guess, we go down here to binom.dist, binomial distribution. Now, when I hover the mouse over it, and unfortunately I can't move the mouse here, but if you see the little pop-up window that came up, the line on top shows you the format, the syntax that we will need to enter here to do this. Now, it's in a different order than it was for the calculator, so if you already watched that, it is, again, be careful, slightly different order. In this case, the number of successes, the x value, goes first. Then the number of trials, n. And then the probability of success. That's what that underscore s is. The number of successes, the number of trials, then the probability of success. Now in the calculator, there were two separate commands for the binomial probability for a single value of x, as opposed to a cumulative probability, that is from 0 up to the x value given. Here it's the same command, we just have this last command over there to make it cumulative, where we would literally have to type the word cumulative. So I'm going to start with the same example that we used there, the same one from the PowerPoint. We're going to have a 10-question quiz. Each question has 4 answers. 1 of them is correct, 3 are incorrect. So here, actually, we get to very nicely put in each thing there, and it even tells you with a description down below with which one you're typing in there. So the number of successes in however many trials. So let's do like we did on the calculator. Let's do 7 successes. It's kind of cool. You see it actually fill in the command with the correct parameters up there. So we want to know the probability of getting 7 questions correct out of 10 trials, where the probability of success on any trial is 0.25, 1 correct answer out of 4 total answers. Now, as for whether we want it cumulative or not, we can just simply leave that blank and it will evaluate it just fine. Oh, excuse me, apparently we need to actually include that. We enter true or false depending on whether we want a single value or a cumulative value. So we enter in false, and that will give us the probability of exactly 7 successes. If you did watch the calculator, you'll recognize that this is actually the same value we had there. Now, I'm going to come down here again, and it might help to label this here. This is the probability that x is exactly equal to 7. What if we wanted to know the probability of getting less than 7 correct? Meaning we could get 0 correct, and that would qualify, but we could also get 1 correct, or 2 correct, or 3 correct, etc. So another way to say this would be not just less than 7, but we could say less than or equal to 6. And that's going to actually jive a little bit better with how we type in the formula. So again, I'm going to do the statistical formula here, binomial distribution. So we want now 6 successes, but it's going to be cumulative, so it's going to go up to and include 6. There are 10 trials, and again, 0.25 is our probability of success. This time, we do want it to be cumulative. We want it to add up all of the values from 0 to 6, all the probabilities for all those values of x. And it's actually kind of cool. You can see the preview of the correct value down here before we even hit OK. And again, if you watch the calculator video, you'll recognize this number, 99.6%. That's what we had in the calculator video too. So between the two, it's kind of showing you, you can see that they are both giving you the correct values. So again, whichever way you choose to use it is fine. Again, this is not perhaps the most elegant way to use Excel, but it's certainly a capability that's built into it, and we can use that. The graphing calculator is possibly just as easy to use. Certainly, as you're working on a test, it's easier to be able to do a calculation on your calculator than to have to change windows, from the test to Excel and then back again. But whichever one works for you, whichever you have available. The Numbers app on an iPad or iPhone, on any Apple device, is going to work again very similarly. Although admittedly I don't know what the command of it is there. I would certainly, if you have a question on that, be happy to look it up for you. But in my experience, most people are using either Excel or the calculator. So those are the two that I gave you here. But again, the Numbers app uses a very similar format to how it does this, because, well, Numbers really is just kind of copying off of Excel, just setting it up differently. So that's how we can get the probabilities for a binomial distribution using technology. And again, there is a mathematical formula for these, but it's a little ugly. Part of the formula involves some stuff that we haven't actually talked about. So for us, it will suffice to use the technology to do this.